Hello, I am Kalidas from Tamil Nadu. I am studying Sri Krishna College of Engineering and Technology. I am doing a machine learning project using Python under Skylab. This is a project assignment regarding the Boston house price prediction. Here the problem statement is we have to train a data to predict the price of the house. Here we have a Boston price data set. It consists of 5 or 6 data points. Each data point has 13 future and our target is price of the house. Now we can start our project. First we can install the Anaconda software and launch the Jupyter notebook and create a new file in Python and save it as linear regression. Boston house price dataset is already available in SKLAN library. So we need to import. Before that we are going to import some library which we are using in machine learning. So we can use function whenever we need it. So we can begin with the numpy. We can import numpy as np, so we can use to access the function of numpy. Next we can import pandas to provide a data structure and data analysis tools. Next we are importing matplotlib as mpl to draw a graph. Import matplotlib.pypplot where plot is the object used to draw a graph. Next we are importing func animation from matplotlib.animation. This model helps to generate an animation that helps to visualize the learning process. Now we can import our data set Boston house price from sklan library using load underscore Boston function. This is the data we are using to train and test the model in our project. Next we are using mean square error function to find the error between the predictor value and the true value. Next we have to split the data set into testing set and a training set. We are using train underscore test underscore pretty function the sklan dot model underscore selection. Now we have to import minimax scalar function from sklan pre-processing. Finally we have to import html from ipython display. This is the library which is used to display the resources on the screen. Let us begin with our first step, that is data processing. First we have to load the dataset using the function load underscore Boston and we are storing the variable in Boston. Now we are using a print function to obtain a description of the dataset. The description is provided by the sklan library. So this is the description about the data set. Here we have to see these are the attributes. Next we can store the future from the data set into the panda data frame. For that we have to pass the data to be stored, that is boston.data, and the data come from boston.data and the name of the column Boston futures underscore name. Now we can print the future data frame. So here we can see such attributes. Now we can see the list of column data contained in future. Next we can store the column target into a data frame called a target. The target column in a data set is also stored as the property of the object with the name target. So we are using the function pd.dataframe and here we are printing the target. So this is the price for each data point. Here we have 506 rows and one column of target. Now we can concurrent future and target data frame into a single data frame using the pd.dot function, where axis is equal to 1 to make the concurrency column wise. Then here we are printing the type of tf and execute. So now we have seen how we can import a dataset into our program. Here the target, it is also concurrented to the remaining attributes. So next we are using the descript function to see the complete description of the data frame. So this description includes count, mean, standard deviation, minimum and maximum value. Here we can see the count for all the remains 506 and the mean for each attributes and the standard deviation for each attributes. That's to perform the linear regression. We have to do correlation function, and the correlation is a statistical technique that can show whether and how can strongly pair of variable in two column are related. Let us consider two column x and y. High correlation means the changes in the value of x causes changes in the value of y. Positive correlation means whether x changes, y also increases. That means whenever x increases, y also increases. Whenever x decreases, y also decreases. Negative correlation means whenever x increases, y decreases, and vice versa. Now we can compute the correlation between attributes and the target values. Here the person is the standard correlation function. Here our object is to find the attributes which having highest correlation with the target value. So we have select each column by using its name from list of future and compute the absolute value of the correlation between each attribute. So now we can see the list of future. We are selecting each value and compute the absolute value of the correlation. Next we have to make the list of pair that consists of correlation value with the label for respective attributes. This can be done using the zip function in Python. So now we want to sort the correlation value in descending order using the sort function. We are using a lambda function to extract the key for sorting, and we want to correlation value in reverse order. So we are setting a reverse is equal to 2, and this will be packed the list into separate element. So we got the correlation value in descending order with the matching labels. Now we can plot the correlation with the respect the target value in a bar graph. So here index is the length of the number of attributes. So here we want to set the size of the figure just wider than the default, and the plot dot bar function is used to generate a bar graph, providing the label for x-axis and y-axis. Here we can see that is x label for attributes and y label for correlation with the target variable, and plot.show function will plot the graph. So this is generate a bar graph. Here we can see L star has highest correlation with the target value. So actually L start is the percentage of largest population in a neighborhood, and next is RM. It is a number of rooms in a house. As the number of rooms in the house increases, target value also increases. So we got which attribute has high correlation with the target. So next we have to move the normalization in the dataset to column may be in a different scale. So this makes it difficult to interpreting the data. So the normalization process being all the value into a column scale. After the normalization, it is easy to interpret the values. So here we are using a minimax scalar function to scale the L start values, and fitted and transform function compute them minimax transformation the value into the normalization value. Fit underscore transform function output will be column wise. So we have to reshape the value. Similarly, we want to reshape the target value also, and here we are printing. After reshaping, we are printing the 5 value of y. Here we can see all the value are in between -1 and +1. Doing learning phase and object is to minimize the error. So actually we have to find the error, that difference between the true value and the predicted value. True value or the value from the data set, and the predicted value we compute from the given weight, that is m and c. So first find the difference between true value and the predicted value. So here we are defining the error function. So inside the error function, we are first finding a difference between the actual value and the predicted value, and find the sum of the square of the difference, the dividing the quantity by dividing the number of sample in the data set to obtain the mean square error. So we can define what the error function is. Next we have to split the data set into training set and testing data. It is difficult to test the model using the entire set of data. So it only percentage of data is randomly choosing as testing data. Here we see that we are using a train underscore and test underscore. This is the function to splitting the data, and we are choosing only point in that is 20% of data for testing. So the function that is train underscore test underscore split, that is from the sklan library, and this will provide a fraction of data and a set for testing the model, and the data shall give on two parts of futures and the target. This will returns x train, x test, y train and y test. So next step for linear regression is to apply optimization technique. The gradient destination algorithm is an optimization algorithm to minimize a function. So now we can see the step of computing the gradient destination. So we have to start with the internal assumption for space position m and c. Then we have to calculate the cost function. After calculating the cost price, we have to calculate the gradient at current position. Then we have to determine the direction to move, then update M and C based on the learning rate, and repeat the step until we get a constant function to an acceptable level. First, we can see how we can use update function to calculate M and C. Now we can define update function. So inside this function, let us compute the gradient underscore M. It is a predefined equation. Next, compute a gradient underscore C. It is also a predefined equation. Then we can update M and C. And here we can see we are using control variable learning underscore rate. Actually, this is learning underscore rate is used to control to how much changes in each integration, and it will returns the update value of M and C. Now we can define Radian discrimination function is used integral function of C, X, T, learning rate, illustration, error threshold. Alliteration is number of times. Error threshold means below the threshold the gradient discrimination process is stopped and wait to return. We have to specify the error threshold. Int it underscore M and int it underscore C is closer to the target value. This number of vibration will be less. So this value was starting point to the gradient discrimination algorithm. First initialize M and C with the internal values. Now declare an empty list to store the intermediate values of error value. During our test processing, we declare another empty list to store intermediate value of M and C. Next, we want to define for in range alliteration. So inside the loop, we are using error function to calculate the error, and they are restored in a variable E. Then we have to check whether the E is the less than the threshold error and risk or threshold. If it is less than the error threshold, we are printing error less than threshold value, stopping gradient discriminant, so it will break the loop. Now store the error value in the list error value, and now we have to update M and C value and update the value to the list in M and C value. After loop complete, return MC alone with the error value MC underscore value. So here we can see how we can run a gradient discrimination. So we are initializing the value to variable like int t underscore m is equal to 0.9 and int t underscore c is equal to 0. Learning underscore rate is equal to 0.001 and illiteration is equal to 250. Error threshold is equal to 0.001. Here we are using gradient discrimination function to assign the argument. Then here we can see double percentage timing is used for magic function. It will build in IPython, so here it will shows the execution time. Next we are going to error plotting. Plot scatter x train y train, color is equal to blue. Then plot scatter x train into m into x train plus c, color is equal to red. The m into x train plus c is using a line equation y is equal to mx plus c. Here we can see the graph will be displayed. Next, plt.plot np.arrange length is equal to error underscore value error underscore value. Here we can plot y label is error and x label is alliteration. Next we can see the visualization of model training. So here we are generating a animation to show the regression line changes over the course of learning. So in order to reduce the process timing of animation, we are choosing small value of m and c. Here the first two values denotes the start and the end, and the last value indicates the interval. So next we are calling plt dot subfunction, which will return two objects. One is figure and another is axis of the object. Then we will get line object using the function plt dot plot. Here x coordinate, they are the empty list and set animation is true. So this indicates that line is to be animating generating an EM and animation request two function. One is to utilize the state of the graph and another function is to update each frame with a new data. So the update function is called drawing each frame. Inside the update function we have to set a new endpoints for the line. So first we can define the int function. In this function we will plot the scatter plot of the training data, and we will use the axis object to set the limit of the axis. That is, here we can see x dot set underscore x limit and x dot set y limit. Image will be set the limit 0 to 1. Then we can define the update function, and which passes integer denotes the frame number. This will update the coordinate for the line in each frame. So here we want to find end point of the line and return the line of the object. In the anim am is equal to function animation is used to update a frame. The frame has a range length as m1 mc underscore value underscore anim to int8 function is equal to int8 comma plot is equal to true. Then html anim to html5 video is used to present the animation for training set model. There will be a animation video will be displayed for 10 seconds. Predicted the value using line equation y is equal to mx plus c. Then mean square error is using set y test comma predicted values. There will be display the output value plt target value to the predicted value. Next, plot scatter x test y test color is equal to blue. Plot scatter x test predicted test color is equal to red. In this graph the line is decreased in the testing data. We are using a inverse transform function to scale the value back to the original representation. So first we must reset the data to change the shape that is required by the scalar using the inverse transformer function to get the original scalar data in stop accurately, it is stored in a variable x test underscore scalar and y test underscore scalar and predictor underscore scalar. Once we scale, we can remove the extra dimension again. We are using a chip function to display the actual price and predict the price side by side. Now we have complete the prediction of Boston cows. We also change the number of attributes by using a normalization of Boston house data. Here change else data, then put rm, and there will be changes in all the function. Thank you.